Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Let us continue more exercises about chapter 4 as a review of chapter 4. Question 15. Here some information are given and we need to sketch the graph using this information. So let us start by graphing and try to understand each of these conditions. F of 0 is 0. This means that the graph passes by the point 0, 0. Okay, f prime of -2, f prime of 1, f prime of 9 is 0. What does this mean? These are zeros of the first derivative, so they are critical numbers. So the tangent line there is horizontal. So it could be, each one of them could be maximum or minimum. So at -2 and at 1 and at 9, okay, there are tangent lines. Okay. Limit f of x when x approaches infinity is 0. So when x approaches infinity, the limit is 0. This means that this line, the x-axis, is a horizontal asymptote. So this line, the x-axis, is a horizontal asymptote. When x approaches 6, this is 6, the limit is negative infinity. And we understand from here that x equals to 6, this line, is a vertical asymptote. And when x approaches 6 from the right or from the left, the limit is negative infinity. So the graph approaches 6 like this. So this is what we understand from here. F prime is negative from negative infinity to -2. So up to -2, f prime is negative, means decreasing. So you can say that the function is decreasing up to -2. If we say that, for example, at -2 the function is here, so we can say that the function is decreasing here from negative infinity to -2. Notice that at -2 the derivative is 0, so we can make it a minimum here if you want. Let us see about other properties, conditions. Also, f prime is negative from 1 to 6. Okay, so from 1 to 6 it is decreasing. Okay, and at 1 there is something. Let us say at 1 it is here. So we can say that the graph goes like this here. Okay, so it's decreasing from 1 to 6. And okay, if I do it like this, then everything is fine up to now. And 9 to infinity. From 9 to infinity, it is also decreasing. Decreasing. So if I say at 9 it is here, can also say that the graph is like this, and it's decreasing. And this is a horizontal asymptote, so it can go like this. Okay. So it's decreasing from 9 to infinity. It's increasing from -2 to 1. It passes by 0, 0. Okay. So let me do it like this. And from 6 to 9, Okay, it's also increasing from 6 to 9. If double prime is positive from negative infinity to 0, okay, so concave up to 0, concave up. And then from 12 to infinity, okay, so this is 12. From 12 to infinity, concave up. Okay, so here it starts concave up like this. So like this, concave up. Okay. Of course, it will approach the asymptote. Concave down from 0 to 6. Yes, from here to here, concave down. So 0, 0 would be an inflection point. And from 6 to 12. Okay, concave down from here to here. Okay, so this point at 12 is an inflection point, another inflection point. So that's it. This graph satisfies all the conditions. If you go back each condition, everything is fine here. So that's the graph of this function. Another question, if is odd. Odd functions means whatever you graph here in the first, whatever you graph here, you rotate 180 degrees. You remember like x cube, like x, okay? Okay, if prime is less than 0, the derivative, the first derivative, less than 0, this means decreasing. The function is decreasing from 0 to 2. Okay, this is 0. From 0 to 2, the function is decreasing. Okay, let me say like this, decreasing. If prime is positive, the function is increasing from 2 onwards. Okay, from 2 onwards, it's decreasing. If double prime is positive, the function concave up from 0 to 3. Good. So from 0 to 3, the function is concave up. Okay, this is good. The function is concave down from 3 to infinity. So it would be concave down like this, concave down. When x approaches infinity, the function approaches negative 2. Okay, so we understand from here that the line y equals to negative 2 is a horizontal asymptote. So let me cancel this now. I have a horizontal asymptote here. This is the line y equals negative 2. Okay, from 0 to 2, let me say it's like this. Don't forget it is concave concave up. At 3, up to 3, it's concave up here. Let me say like this. At 3, up to here, it's concave up. And then, okay. And then after 3, from 3 to infinity, it's concave down. Concave down. Like this, it will not be concave down. So I have to do it like this. Maybe up to 3, yeah, and then it goes like this. So it has to approach the asymptote from below. Okay, if you took it up and approach the asymptote like this is concave up, not concave down. So being concave down from 3 to infinity, this means that it approaches the asymptote from below, not from above. Now the function is odd, so all the conditions satisfied here. From 0 to 2, it's decreasing. From 0 to 2, it's decreasing. From greater than 2, it's increasing. So starting from here, it's increasing. Okay, like this. And the concavity is now also is good. Now the function is odd, so I have to continue the graph because the function is odd. If the function is odd, then I must have this line y equals to 2 as a horizontal asymptote, because the graph will continue now like this. Okay, it will go like this, and at up to -2, okay, and then it goes like this. So the same graph from here, you do it up. Okay, so this would be the graph of this function. It is not that accurate. Okay, try to make them equal, the same, like this. So please, yeah, I don't have a pencil. This almost the graph. It has to be an odd function. Now sketch the graph of this function. You remember in section 4.5, we have to find a lot of things. First, the domain or real numbers, because this is a polynomial. What about the x, the y-intercept? We put x0, the y-intercept is 2. X-intercepts, I don't think it is easy because it's cube x to the power 3. You have to put negative x cube minus 2x plus 2 equals to 0 and try to solve this one. Okay. So if you want, you can use the calculator. Mod 5, 4, -1, -2, and 2. Yeah, the solutions are 0.7 and -2.7 and 0. How come 0? Yeah, there is a mistake. 0 cannot be a solution. So I forgot to put the coefficient of x squared. It should be 0. So 0.8 is the first solution. And the second and the third solutions are complex numbers. So this is the only real solution, approximately 0.8. Okay, so this is the x-intercept. What else? Let us find the limits, vertical asymptotes and horizontal asymptotes. When x approaches infinity, we take the highest power. Infinity to the power 3 is infinity, so the answer is negative infinity. And when x approaches negative infinity, also I deal with the highest power. Negative infinity to the power 3 is negative infinity times negative, so it is infinity. So I understand now that the function when x approaches infinity, it goes to negative infinity, and when x approaches negative infinity, it goes to infinity. Okay, this is what I got from here. Also, the y-intercept is 2. And the x-intercept is here, for example, 0.8. Okay, let us, of course, no vertical asymptotes, no horizontal asymptotes. What about the symmetry? Let us find f of negative x. It would be 2 minus 2 times negative x minus negative x cube. So it's 2 plus 2x. And negative x cube would be negative x cube. This negative will come out, so it would be positive x cube. And this is not equal to f of x, and it is not equal to negative f of x, because negative f of x is negative 2 plus 2x plus x cube. So this function is neither even nor odd. Neither even nor odd. All right, no symmetry. So that's because the number, okay? Because if you remember 2, this is 2 times x to the power 0, and 0 is not an odd number. If you say to yourself, this is 1, 3, it should be odd. Because of this 2, the function is not odd, it's neither. Okay, now let us find the first derivative. First derivative is negative 2 minus 3x squared, because the derivative of 2 is 0. To find the critical numbers, let us put the derivative, the first derivative equals to 0. So 3x squared would be equal to negative 2. Okay, this is impossible. X squared equals negative 2 over 3. This is impossible. So no zeros. This function has no zeros, no real zeros. So it has to be either positive or negative. Well, negative, negative, it is positive. Actually, I can write it negative. If I take negative as a common factor, then I see that 3x squared plus 2 is always positive. So f prime is always negative. So the function is decreasing from negative infinity to infinity. The function is decreasing. Yeah, so it seems that it goes like this. If the function is decreasing, then it's going like this. If this is, yeah, like this. I'm expecting here. So this is 1 and this is 0.8, okay? Let us see the other properties, but up to now, this graph is okay. Let us find the second derivative. Well, the second derivative, derivative of negative 2 is 0, it's negative 6x. And this has 0 as a 0. And to the right of 0, 1, it would be negative f double prime. And to the left of 0, if you choose negative 1, negative 2, f prime would be positive. So here it's concave up and concave down, and 0 is an inflection point. If I put x0, y would be 2. So this is the y-intercept. So the y-intercept is an inflection point. Okay, so now I can, from here the graph is concave up, and from here the graph is concave down. Okay, and 0 is an inflection point. 0, 2. So that's all. These are all the information. No extreme values because no critical numbers. no zeros, so no critical numbers. No critical numbers. No extreme values. So this seems the graph of this function. You can choose more points, -1, -2, just to make the graph more accurate. Another polynomial. So the domain consists of all real numbers, and the y-intercept is again 2, and the x-intercept, I have to solve this equation, and it's not easy to solve this equation, but also I don't have the calculator does not solve degree 4, although there are some calculators. So to find the zero, to search for a zero, I can replace x by 1, okay, 3 minus 4, -1 plus 2 by 2, okay, like this, by certain numbers by 3. But if you do not find, then it could happen that there are no x-intercepts. This equation could have uh, 4 non-real zeros. Okay, so I'll postpone this, and I don't have a way to find out. So let me go to the other things. Let us find the limit of y when x approaches infinity. And this means we will deal with 3x to the power 4. It is the highest power. And this is x to the power 4. So in fact, replacing x here by infinity or negative infinity will give you the same answer, because this is x to the power 4. The sign will disappear. So the limit is infinity. So for this function, the limit is infinity from both sides, not like the previous question. It goes to infinity here and it goes to infinity here. And this exactly what we know actually about x to the power 4. Usually x to the power 3, one end behavior, one end will be up, the other end will be down. But for x to the power 4, either both go up or down. So this agrees with our information. What else? Let us discuss the symmetry. Well, this is x to the power 4, this is x to the power 3, so it is neither. So if you find f of negative x, you will have negative x to the power 4 will give you x to the power 4, but here negative x to the power 3 will give you positive. And this is not f of x, and it is not negative f of x, because negative f of x is you multiply by -1. So the function is neither. Okay, of course, no vertical asymptotes, domain or real numbers, no horizontal asymptotes, because the limit when x goes to infinity is infinity. Okay, so let us go to calculus and find f prime. F prime is 12x to the power 3 minus 12x squared. Okay, let us try to find the zeros here. Well, I can take 12x squared as a common factor. So I have x minus 1. When you put it equals to 0, I have two zeros, 0 and 1. So I can put 0 and 1 and negative infinity and infinity. And let me discuss the signs of f prime. Well, x squared always positive, 12 always positive, so x minus 1, everything depends here. If x is greater than 1, it would be positive f prime. If x is less than 1, half, it would be negative. -1 also negative. So these are the signs of f prime. So decreasing, decreasing, increasing. So we have a local minimum at 1 and f of 1. And f of 1 is 3 minus 4, negative 1 plus 2, that's 1. So 1, 1 is a local minimum, and there is no local maximum. If 1, 1 is local minimum, okay, so it seems that the function is from here, it's going like this, and it's going like this here, okay? Let us continue more information. It should be, yeah, increasing. Here it's increasing, here it's decreasing. But there is something at 0, because at 0, uh, 0 and what? What is the y-intercept? The y-intercept is 2. So at 0, 2 here, there is a horizontal asymptote. Okay, there is a horizontal asymptote. So it could go like this and do something like this, and then continue up. It could happen that the graph like this. We will see with the concavity. The concavity will give us more a clear image about what happens here. All right. So let us find f double prime. 3 times 12, 36x squared minus 24x. Well, 8, 12, I can take 12x as a common factor. Then I'll have 3x minus 2. If you put it equals to 0, I have 0 and 2 over 3. These are two zeros of f double prime. So what is the sign of f double prime? Well, it is x squared. So between the two zeros, the sign is negative, opposite to the sign of x squared, and here the sign is positive. So concave up, concave down, concave up, and I have two inflection points, 0 and 2, and 2 over 3, and f of 2 over 3. And f of 2 over 3 is 3 times 2 over 3 to the power 4 minus 4 times 2 over 3 to the power 3 plus 2. And that's 38 over 27, which is approximately 1.4. 2 over 3 is 0.7. So here 0.7 and 1.4, this point is an inflection point. So it is concave up here from 2 over 3 to infinity, concave up. From 2 over 3 to 0, it's concave down. So this part now is concave down. Okay. And then at 0, it goes like this. After 0, it's concave up. From negative infinity to 0, it's concave up. 0 is an inflection point, and 2 over 3 is also an inflection point. 1 and 1 is a local minimum. So this is the solution of this function, and it has no x-intercepts, as we can see. So this equation has no real zeros, it appears. I'll stop here, and I'll continue the rest in another video.